Hello, everyone, and welcome to another video on Module 3. In this particular case, we're going to talk about formulas versus functions. Again, in the textbook, this is the chapter where we start moving into some of the computation calculation. And for some students, they interchange the two words formula and function, whereas in Excel, there is a technical difference. And so when we talk about a formula, typically, we're talking about a mathematical expression, whether that's adding two cells together, like we did in the hypothetical student budget, and we said we'll take their job one income and add the job two income, and that is an arithmetic expression. You're doing the math of addition. When you do a formula in Excel, you can do all the same math that you could do on a calculator: addition, subtraction, multiplication, division. You can put in parentheses. You can put in uh, exponents, any function that you might see in a textbook, you certainly could convert into an Excel formula. The thing you have to be careful about, and Excel is very good at it, but humans aren't always, is that you have to remember the standard order of operations in algebra that you learned probably in late elementary school, middle school. Some people remember PEMDAS, or please excuse my dear Aunt Sally. When you give Excel a mathematical formula and you type in all of the mathematical symbols and parentheses and exponents that you might need to do that calculation, it's going to follow the standard order of operations in terms of how it evaluates that. And so if you leave out parentheses where there should be, or you don't put parentheses, you put parentheses where there shouldn't be, you could end up telling Excel, to do something than perhaps you intended. And so again, that's always a bit of a sticking point for people. In Excel, the multiplication symbol is the asterisk, shift 8. That also sometimes throws people for a little bit of a loop. And so we can do all the math that we would typically do on a calculator in Excel with a formula. And certainly there's benefits to doing that. But if there are things that we might want to calculate where we don't either know the exact mathematical calculation, or it's a complicated calculation that we don't want to necessarily make a mistake in entering or transcribing. Excel has functions involved, and we've already seen at least one or two functions already. Functions are different than formulas. Again, in a formula, you say equals, and then you do whatever addition, subtraction, multiplication, division, etc. that you want. In a function, it is something that is pre-built. It has a name. It has specific purposes, or a specific calculation that it's going to carry out, or a specific operation. Not all functions do math. We saw that already. We saw the equals today function. Its operation is to simply display the current date. And so we've used the sum function. We might have used the average function before. Again, they are functions where we might know an average is add up a bunch of values and divide by the number of values. But doing that with a large set of data could be cumbersome. And so it's instead easier to simply say equals average and then highlight or type in the cell range that we want to do that average function on. And in Excel, I just Googled this because it changes from version to version. There's over 400 functions in Excel. People are sometimes a little bit get anxious over that. I think the number that came up in my Google search was about 450. But in this class, we're not going to learn 450 functions. I know a lot of functions, but I don't know 450 or 400 functions. In this class, we're probably going to learn somewhere in the ballpark of 25, maybe 30 functions, which is just a sliver. Those 400 functions are organized into categories. There's mathematical functions, there's statistical functions, there's engineering functions, there's database functions, there's financial functions. I'm leaving out some other date time functions. There are a whole bunch of functions. But for the average user, and certainly the introductory student like you don't need to know every single function. We can learn 25 or 30, get an idea of the syntax of how they work. And then the idea of learning software, and one of the big takeaways from this course is not just learning the things that we cover in the textbook, but also learning how to learn software. that, when you go into the workplace, you're going to be expected to use software that isn't Excel. It isn't Word. It's, something you've never seen before. Again, you're going to have to, and they're not going to just throw you in cold turkey, but you are going to have to, find your way. You're going to have to be comfortable with learning to learn things. And even if you get a job and you're using Excel and you're pretty good at it after this course, Excel is always changing. There's new things, there's new formulas, there's new functions, there's new bells and whistles. And so, whatever the technology might be, we have to be continually learning. And so part of this class is, getting used to and learning 25 or 30 functions and being able to say, oh, this function is a lot like that function. And if I know how to do this function, I can figure out from either the Excel help or online tutorials or a little bit of guidance from a site online how to figure out how to use this new but slightly different function than something we've used before. And so the textbook is very specific because we could try to learn 400 functions, and in 16 weeks, that would mean we'd have to learn 20, 25 functions a week. That's like five a day, is that's not feasible. And there's no reason to, because a lot of those functions you're never going to use unless you're in that particular area. Unless you're an engineer, you're not going to use many of the engineering functions. If you're not a finance major, you're probably not going to use a lot of the specialized finance functions and so forth. And so again, we're going to learn about 25 or 30 of the basic functions, a little bit of variety on in this particular demo. We're going to talk about a particular finance function that certainly you would use if you're in finance, but also if you're just a general consumer, it's a function that you might use in a number of different circumstances. So don't get too anxious about formulas versus functions. We'll be using some formulas at times. SAM assignments will tell you how to do it. Again, if I want to add up a bunch of numbers, I can say A1 plus A2 plus A3 plus A4 plus A5, or I could say equals sum A1 through A5. And in chapter three, Sam is very specific, and in future chapters, Sam is very specific about use this function to calculate this result, or write a mathematical function, a mathematical formula to do that task. And so, again, understand the difference between formula and function. And so the example we're going to look at is a car payment calculator. Again, you may not have bought a car in your lifetime yet, but certainly you understand the idea that you might need a new vehicle for transportation, and new might mean new to you, not necessarily brand new. But most people don't have the cash laying around to just walk into a dealership and say, here's my briefcase, I'm going to walk out with a new car. Instead, we might have to take out a loan. And if you're a finance major, or even if you take personal finance, you'll spend some time talking about, the idea of loans and paying it back with interest and et cetera, et cetera. And if you had taken Finance 331, there is a section on loans, and the mathematical formula, the mathematical the syntax that you would see in a textbook for calculating a monthly payment on a loan is pretty complex. I don't have it here, and I could certainly Google it. But it's got a numerator, denominator. It's got things to the exponents. It's an ugly thing to try to solve by hand. Most finance textbooks aren't going to have you do it with pencil and paper. You're going to use a financial calculator. You're going to use Excel, etc. And so in this case, we want to build a spreadsheet that will allow us to calculate the payment on a car when we take out a loan. And so in this, we have to think about, well, what does Excel need to know? And in an in-class situation, we'd walk through this demo a little bit more and get some responses. But certainly in this case, I'll interject some of the responses. And so the first thing we might not need to know is something about the car that we're going to buy. And oftentimes when we do this in person, people will talk about, well, the price of the car. Certainly the price of the car is important. Sometimes the price is the price. Sometimes you can negotiate the price. But you also then have, well, what about if there's a down payment? I brought $1,000 to put down, or I have a trade-in because my old car, has some life in it. And so maybe they'll buy that from me as a form of a down payment. And so what we really need to know is, how much money are we going to need from the bank? What is the amount of the loan? And so I'm going to boil that down to a single number. We also need to know how long are you going to take that loan out. And again, typically car loans are denominated in months. So how many months are you going to take to pay this back? Again, it could be 12 months, it could be 60 months, it could be 84 months. Typically, car loans don't go longer than 84 months because, again, you don't, that car may not last 7 years, or by the time you get to year 7, 8, 9, the car is worth very little, and the bank is worried about will you continue making those payments? In the earlier years, if you don't make your payments, they know the car has value and they can come back and repossess it. And so we need to know how long are you taking out the loan for? And then we need to know something about the interest rate. And in some cases, I could build a spreadsheet where I have simply a cell to enter the interest rate. In this case, I'm going to add a little twist. I've got a business rule off to the side to say, well, we've got two different interest rates. If you got excellent credit, we're going to charge 6% as the car dealership. And if you have good credit, no, I said good. Typically, realtors and bankers aren't going to say you have bad credit. They're just going to say, well, you don't have excellent, you have good. In real world, you might have multiple, more than two categories of credit, and they would use credit scores as ways to kind of put you into a category. And so we know that we need an input for the amount of the loan. We need an input for the length of the loan. We need to know something about the person's credit quality. And that credit quality is an input, but the interest rate is going to be the result of a calculation. So if you give me your credit quality, I can then tell you what the interest rate is. And I'm going to use an if function, again, something from chapter 3. And I'm going to say, well, if this cell C8 equals excellent, and again, I put excellent in quotes because we're trying to match text. The value of true is going to be 6% or 0.06. And if it's false, in this case, there's only one other choice. Oops, and now my cursor is getting a little wonky here. I'm going to have the value of false as 10%. And so when I do that and I hit enter, I'm going to get a response. And if I type in that I have excellent credit, it will charge 6%. And I could format that with a percentage sign so I don't get confused. And in this case, maybe we'll say, I want to buy a $20,000 car or take out a loan for $20,000. I'm going to do it for 5 years or 60 months. And so what I want Excel to calculate is my monthly payment. And again, there is a mathematical formula. I could find it on the web. I could find it in a Finex textbook, but it's complicated. And so I'd rather use a function in Excel called the PMT function. And it has a number of different arguments. The first thing it wants to know is the interest rate. So I say, okay, that's in cell C10. Then it wants to know NPER. That's the number of periods or the number of months that we're going to pay this back in. I put a comma. It asks me, what is the present value of the money that you want to borrow? I'm going to put that in cell or put C4 as that entry. The last two arguments are in square brackets, meaning they're optional. The fourth one is future value. The default is 0. They assume you're going to pay off the loan after 60 months. And the last one has to do with the type of interest payment. We're going to leave that as a default. We don't have to enter anything. And so we're going to enter just those first 3 required elements. And when I hit enter, Excel is going to give me a calculated value. Turns out to be $1,237.51. And in this particular case, I led you a little bit astray because I wanted to make a point to say we don't want to blindly accept what Excel gives us. In this case, does it make sense that you would make 60 payments of $1,200, essentially $72,000 over 5 years to buy a $20,000 car? Do you know anybody who pays $1,200 a month for a car payment? Probably not. That sounds outrageous. And it is, because in this particular case, even though Excel calculated it and it calculated correctly, there is a important piece that I need to know that when I use the PMT function, and it asks for the rate. It wants the rate per period, not the annual interest rate, which is what we oftentimes see on TV or see in an ad, the 6%. We need to take that annual interest rate and divide it by 12. And so instead of paying 6% per month, we're charging a half a percent per month, which adds up to 6% for the year. And when I make that change, that will give me what is the correct answer, which is if I were to borrow $20,000 for 60 months with excellent credit that gave me a 6% interest rate, my monthly payment would be $386 or $387. You notice it's in red, it's in parentheses. That's a sign that it's a negative number. That's a formatting setting for currency and accounting data. It's a negative cash flow. So it's money flowing out of your account. When you take accounting, you'll talk about cash flows and credits and debits. Again, we don't have to be too worried about that in the sense that the number is the amount of the payment. And so that gives us a quick demonstration of a financial function for calculating the monthly payment on a loan. I should note this model and this function works exactly the same if I'm talking about buying a house. If I'm going to buy a house with a fixed interest rate for a fixed period of time, the calculation is exactly the same. The function is exactly the same. The numbers are just bigger because I'm going to borrow hundreds of thousands of dollars potentially, and I'm going to borrow for, in many cases, a 30-year loan, which is 360 months. But what the PMT function doesn't work for is if I have a variable interest rate on a mortgage. Some mortgages, your interest rate goes up and down with the market. This one assumes that it's a fixed calculation. This also doesn't work with credit card payments. Again, a credit card is different than a loan because with a credit card, you can charge a bunch of items, you can pay it off, you can pay part of it off, you can then, the balance goes up and down. Whereas with a car payment, you get the check to pay the dealership, you get one lump sum of money, and then you pay it off over time. And so that is a very different kind of arrangement than a credit card where you get a credit limit. You can charge it up, you can pay it down, and balance can bounce around. And so the monthly payment on a credit card is calculated in a very different kind of way. And so that is our financial function here in chapter 3. Again, stay tuned for more videos.